Hey class, how's it going? We got our new topic of energy. So we finished our dynamics and forces. We're still going to be using that kind of going forward. Same with kinematics, but we're going to enter a new unit that you probably have not really dealt with in grade 11, which is our energy unit. So this is just going to talk about two main things. And so the main things we're going to be talking about is potential energy and kinetic energy. So potential energy. Wow, that's not how you write an E. It's a Friday. Potential energy and kinetic energy. And our symbols are basically our P, E, and Ke. And so this is basically, again, we're going to measure this also in joules. Also just a J. All right. So what we're talking about when we're talking about energy is we're basically talking about, like, if I hold this up here, this has potential energy because of gravity. This is going to want to go down, and so there's going to be some kind of velocity. There's going to be some momentum. We're going to talk about momentum in a couple weeks. But you've probably heard the word of it before, and we used it a little bit in grade 10. But there's the potential energy of it to be able to do something, to kind of like to apply a force or to have a velocity and all that kind of stuff. Okay, so that's what potential energy is. It is something that is raised above like zero. I'm going to say ground level is zero. So something that is raised above ground level has potential energy because it could fall or it could roll or it could slide down something. And then it has that, like, because it was at that level, it can now gain velocity. It can do work. It has a force. It can act as a force on something else because it possibly has an acceleration. That's what energy is. Energy is, it is a moving energy, which is our kinetic, or our potential energy because it is at a certain height, and so now it can possibly create that new thing. Okay? And so I kind of alluded to that kinetic energy is when something is moving, it can apply a force or it has an acceleration, it has a velocity, and so therefore it is doing something. It has energy. Okay, and so both these have a formula, and our formulas are pretty nice. I'm just gonna get my red mark over here. For potential energy equals mgh. Okay, and what mg is, mass times gravity, so like 9.8, our acceleration of gravity, 9.8, times our height, whatever height we're at. And that'll give us our potential energy. Kinetic energy is 1/2 mv squared. So 1/2 times mass times velocity squared. That'll give us our kinetic energy. Okay? And so the big thing that I'm going to talk about in the next 2 or 3 videos is basically our conservation of energy, or how energy is transferred from one of these to the other. Okay? And so when I have potential energy, let's say I have 50 joules of potential energy, once it gets down to ground level of 0, all that potential energy is gone. It should have transferred that energy into kinetic energy. Okay? Because I cannot just create energy. Okay? I have to be able to like conserve that energy. It has to be to go towards something. Okay? And so I want to talk about just an example of that, of how to kind of look at and figure out potential energy, how to figure out kinetic energy, and kind of how to use it in like a little question. So let's say I'm on top of a mountain. Okay, so there's Mr. Westwood's on top of a mountain, and I decide to drop, I don't know, an apple, a tennis ball, something. Okay, let's say I'm at, let's make it a little different. Let's make it a bowling ball, that way it has some bigger mass, okay? So I have a bowling ball. Why am I dropping over a cliff? I don't know. So this is going to have a 3 kilogram mass. And let's say we are at a height of 20 meters. So pretty high up. All right, so what would my potential energy be of this bowling ball? Like, not my potential. What would the potential energy be of the bowling ball? Well, for potential energy, it would be mass, which is 3 times gravity, 9.8, times 20. Okay? And if I do that very quickly on my fancy-dancy calculator, I get an answer of 588 joules. So I have a potential energy of 588 joules. All right, let's say I then drop this bowling ball, and it goes all the way down to 0, like height of 0. Okay? At the height of 0, I now have 0 potential energy. Okay? Because I have a height of 0. Like, if I were to have something on the ground, like I'm on the ground, I have no potential energy. I can't drop and hurt something. I can't drop and have a force or a velocity. I'm already at 0. So down there it has potential energy of 0. But energy, again, is conserved. It is transferred from potential to kinetic energy. So what is my kinetic energy at the bottom? Well, my kinetic energy is going to be exactly the same as what it was at the top. So I've transferred all my potential energy to kinetic energy. So now my kinetic energy is going to be 588. So that's what my kinetic energy is. If I use that kinetic energy, I can figure out actually how fast it's going, like the velocity that it's going. So let's actually use this. My formula is 1/2 mv squared, and I know that it has to equal 588. So if I kind of basically take this, I have a mass of 3. Let's actually figure out what this velocity is. So I'm going to take 588, I'm going to times by 2, basically get rid of this half. And then I'm going to divide it by 3, so I get v squared is going to equal 392. Again, all I did is there times by 2, then divide by 3. And then I'm going to take a square root of this. So square root of 392. And I get a velocity of 19.8. Velocity of 19.8. Now that we're introducing energy, this is another way to kind of calculate a little bit of some of the questions that we've done, but a little bit differently. Could we have figured out the velocity a different way? Yeah, for sure. You technically don't even need mass. If you want to go into our kinematics, if you have a VI of 0, you could have done 1/2 AT squared, which you possibly could have done that way. Or if you, because you already know the distance, or if you wanted to figure out velocity this way, again, you could have figured out kind of this way. All right, you have 2, you have the acceleration, you have the distance. If you wanted to figure out velocity final, this would kind of be a way that you could do it. But this is another tool using our energy way. Okay, so potential energy, kinetic energy. We're going to talk about the conservation, like it has to kind of be the same, okay? In my next video, I'm going to talk about basically, I'm going to go through a few of the examples in our practice sheet, okay? So in your Teams folder, there's conservation of energy practice sheet. I'm going to make 2 separate videos. One kind of going through the first 5 or 6 questions, another video going through the second half. Just kind of showing you how I would tackle these questions and how my thought process is going through them. There is already the notes, the answer key there. Some of those answers I'm going to do exactly the same, follow the exact same steps. Some of them are longer in the formula way, where I may do them a little differently. I like to break things up a little bit differently and kind of do them in a different, just tackle the question a little differently. So that'll be my next 2 videos, kind of talking about conservation energy. All right, thanks class.